The 21st century has witnessed an unprecedented surge in technological advancements, particularly in the realm of artificial intelligence, or AI. Deep learning algorithms, inspired by the structure and function of the human brain, have demonstrated remarkable capabilities in tasks that were once considered exclusive to human intelligence. These networks learn from vast amounts of data, identifying patterns and making predictions with astonishing accuracy. From self-driving cars to virtual assistants, deep learning is rapidly permeating every aspect of our lives. The impact of deep learning is undeniable, driving innovation across diverse fields such as healthcare, finance, entertainment, and transportation.
Neural networks, the building blocks of deep learning, are intricate systems designed to simulate the information processing capabilities of the human brain. Just as our brain learns from experiences, neural networks learn from data, gradually adjusting their internal parameters to improve their performance on specific tasks. A neural network consists of interconnected nodes called neurons organized in layers. Each neuron receives input from other neurons, performs a simple mathematical operation, and passes the result to neurons in the next layer. The connections between neurons have associated weights representing the strength of the connection. During the learning process, these weights are adjusted to minimize errors in the network's predictions. Activation functions introduce non-linearity into the network, enabling it to learn complex patterns and relationships in data.
Over the years, researchers have developed a variety of neural network architectures, each tailored to specific tasks and types of data. Feed-forward neural networks, the simplest type of neural network, process information in one direction, from input to output. They are commonly used for tasks like image classification and pattern recognition. Recurrent neural networks, or RNNs, possess a unique ability to process sequential data, making them ideal for tasks involving time series data, such as natural language processing, speech recognition, and machine translation. RNNs have a feedback mechanism that allows them to retain information from previous inputs, making them suitable for tasks where context is crucial. Convolutional neural networks